When designing a building that the columns on the ground floor are not in the same positions with the column on the first floor or other floors, then you will have issues with your structural design, knowing that most of the building plans are not well drawn, and because of that they don't have the same alignment on the ground floor and on the first floor and all that. Or if you have a cantilever around your building perimeter, there is 100% chance that the columns on the ground floor around the perimeter won't be the same with the columns on the first floor around the perimeters and all that. So with this becomes a challenge for younger engineers and also for most professional engineers to perform the structural design or framing of that building. So in this video I'll be showing you how to perform all this. Okay, so right now, as you can see, these are the columns on the ground floor. We have already done the framing for the structure on the ground floor. As you can see, all the columns here on green are for the ones on the ground floor. When we now copy the column onto the first floor here, we then notice that most of the columns are appearing on empty space, which are causing what? Obstruction to the people using this structure. So in that, we will have to do what? Hide these columns. Else, if they come out like this, as they are coming out on empty space like this, they will cause obstruction to the people using this structure, and it is not nice. So you can see that over 98% of the columns that we did on the ground floor here, when coming to the first floor, you can see that they are coming out on empty space. All the red ones here are to be what? Are to be removed, are to stop at the what? At the slab. While you can see that only 3 of the columns are still hiding inside the walls. Then you can now see when we now arrange the column now to hide it again inside the walls on the first floor. This now implies that these columns on blue are going to sit on a cantilever slab and all that. And most of the times, most clients don't like to see cantilever beams on their building because it tries to change the beauty of the structure. So if you look at now, we have done basically the structural model of this structure. So if this is your first time watching this video, I would say that you have missed the part 1 and the part 2. So this is basically the part 3 because we have done the model of this structure, which I'll show you just now. So let's now dive into the structural model of this structure. So you can see the structural model of this structure, and the software we are using for the design of this structure is Protastructure. So you can see how we have modeled for the ground floor, and if I now walk you through to the 3D view of the model, you can see how the columns on the ground floor are all terminating. Can you see that? And then we now put another column again on the upper floor. So all the columns you saw on red are what? Terminating on the ground floor, as you can see them there. And then we now have new other columns being introduced on the first floor, which will start from the slab down to the roof, as you can see that. Okay, that's fine. Then you can also see how we used a beam depth of 150, so that even if the client does not want the beams to appear, knowing that column cannot sit directly on the slab, it will cause a point load on that slab. Okay, yeah. Although there are some principles and rules when column can sit on the slab, but just know that basically from theory it is not good for column to transfer its load directly on the slab, except you are designing for what? For a flat slab and all that. So with this now, we have to model what? A 150 depth of beam, which you're going to hide inside the slab, as you can see that. So on the part 1, we perform the structural framing, which you just saw, and on the part 2 of this video series, we perform the structural modeling, which you are seeing here. And on the part 3, we then perform the structural modeling of the upper floor, where we have to now make the changes of the columns that are going to stop at the slab, and the ones that will move onto the what? Onto that will start from the slab. Okay, that's fine. So right now in this video, which is in this part, I'll be showing you the structural analysis and design of this structure, because most people cannot design for a beam depth of what? 150. When your beam depth is 150, they have issues on that design. So I'll show you how to perform that. Now before we go on that, I will show you one thing, and that is what? You can see that I applied hinge at the end of my beams. Okay, at the ends of every beams. Okay, I didn't consider this 150 beam as a beam because I still consider it as a slab. Okay, so it will be inside the slab and all that. So that's why I also hinge this place, because I didn't consider this as a beam. So this beam here is not a continuous beam to this end. Okay, that's fine. So let's now begin what the structural analysis first and see if there is any warning we are going to see based on the model check. So let's go and perform the model check first and then begin with the structural analysis. Okay, that's fine. Now before we can go for the BD model check, there is one thing I like to do, and that is what, to change my grid line naming. As you can see that this software basically names its grid line automatically, so it is good to use a customized grid line, which is what, 1 2 3 4 5 and then A B C D. Okay, that's fine. So I'm going to turn all my vertical grid lines to be what, alphabetical, and then I'm going to turn 1 2 3 and then turn all the horizontal grid line to be what, A B C D and all that sequentially. Okay, that's fine. So with that, now I'll just come here now, click on this, right click now and then do what, properties here, and then change this now to gridline what, gridline 1. Okay, and then say what, update, and that will change. So I'll do this now for all the other grids and all that. So as you can see now, using the same procedure, I was able to change all my grid lines to 1 2 3 4 5 6, to up to 8, and from A to what, to D, to G. Can you see that? That's fine. So it is a good culture to do what, for you to do this, because it will impact it on your structural detailing. Okay, that's fine. So with this now, I will then go on and then save. So we are now about to enter into the building model check. We will have to see if our model is okay or not okay. Okay, that's fine. Let's now begin with the building model. Now I will then click on this place that says what, analysis tab here, and then come here and do what, building analysis here and all that. Okay, so make sure you follow these steps, and the last step, which I will use on the towards the end of this video, you will not like to miss it. Okay, and then come now and then come here and do what, first I want to do what, edit my what, materials. Okay, so I'll come now and edit materials and all that. I want to use my concrete grade to be what, grade 20. So I'll come now and choose what, grade 20 here, and make sure you put your eyes here that this is what, grade 20, and I will apply to all what, all members, and then say okay, and then come now and then choose what, my grade of what, of my bars, which is the steel. All right, I want to use what, grade 410 or grade 460 and all that, and then come here and do what, click on what, okay here. You can use grade 410 or 460, that's fine. And then come now and then click on what, okay here, and then on the rebars now you have to come here and do what, click on this place here that says what, rebar diameter, and then come now and choose. Now for the columns, I want to choose what, rebar for first of all I'll come here and do what, uncheck all. Okay, and then come and choose what, 16 and then 20 maximum. Okay, and then okay, and again I don't have wall here. I'll come to beam right now, click on beam here, and then do again here. I'll choose what, I'll choose 16 and then 20 at maximum. That's fine, and then okay. And then for my slab, I will choose only 12 for slab. Come here and choose 12 for slab, and okay. And then for links now, I will come now and then choose what, Y10 T10 for links, and then come here and do what, say okay. That's fine, and everything here remains the same. I'll come now and do what, say okay here. Now before I go again right now, I have to come here and do what, load my what, combinations. Okay, let me just confirm if that is being loaded. If that is there, I'll click on this place now and make sure you can see that it is not here, and then come and do what, come here and do what, loading generator, and then come and do what, say okay. There is no wind load for this, so just say okay for that, and then say okay. That's fine. Now we then enter into what, building analysis here, that says one here. Now on this place first, the first thing I'll do is to do what, to check for what, building model check. Okay, that's fine. So I'll come now and then click on what, building model check here. I'll click on this button here and then do what, say start. Okay, so I'll check out for if there is anything like overlapping and all that. Okay, but if there is any other smaller warnings, we'll just ignore it. So right now we have what, 2 warnings. Okay, 2 errors. Let's go and check what the error is by scrolling up. Okay, you can see that they are saying that slab 24 have very smaller area. Yeah, I believe it's around this place here. And slab 25 have very smaller, very small area. Okay, so let's go and check out these two. Although this is not a big warning, so let's go and check out where this slab is, 24 and 25. Let's go and see that. So I'll come now and then click on what, and then click on close first, and then go and look out for what, for those 2 slabs and see that. So 24, let me see where it is. Okay, that's fine. Yes, that's okay. You say you have a very small area. That's fine. 25 to 25. That's okay. So with this, that's not a big issue of for like an error or warning. So I can just ignore that and then come now back to my analysis tab here. Okay, and then we will now begin into the building analysis. So since there is nothing like what overlap on our model and all that, we will now enter into the building what analysis and design and all that. So with this now, I will then come again here, click on this place again, analysis and design now, and then come here and do what, check all to check these two, and then come here and do what, reselect bar if any failure, and I'll do what, start. By clicking on this start now, what it means is that it has now begin what, the building what, check again. It's trying to check for what, for the building what, connectivity, and then doing what, right now it's trying to do what, it's trying to do the building what, analysis. Okay, after now it is now into the building design stage, so it takes less than 2 minutes to perform all this for you. Okay, so let's just hold on for that to complete now. So you can now see that it's now entering what, into the building design. So if you want to join our Ekidel mentorship class, today is the last day for what, for the for our discount price. Okay, so if you don't enroll today, there will be no chance again for you to enroll using the discount link. Okay, you have to pay the full amount of for the training. Okay, so let's just hold on now for that to complete. Okay, so if you're new on Ekidel, please consider subscribing and all that. Okay, see you then. So with this, I can see that we are now done with what the whole design. It took only 50.32 seconds, which is less than 1 minute. Okay, so right now do what, say okay here, and then I will then come now and do what, click on what, close here. Okay, so when you're done, once you're done with your building design, all right, you have to do what, to do what they call building model check, sorry, building design and status. Okay, check. Okay, so I'll come now and this place that says what, interactive design here, and then come here and says what here, that scroll down and do what, design status here, and then click here. So you can see that most of the beams are failing. As can, sorry, they're not failing, they have warning sign. As you can see that yellow here means warning, red means failure, green means okay. So you can see that most of our beams here, no one here is showing red, but we have slight warning. So we can check what the warning is actually. It might be that they need to increase the either to arrange how the bars are to be arranged well. So let's now look at all those warnings now. So with this now, so if I now go again now and 3D view now, and then check again on checking here again, just to check again for the status again, come here now and check again, you can see that most of the beams are fading again. Okay, so with this now, back to our plan view now, let's now begin to do what, check out for the ones that are showing yellow first. Although it's a good culture to check for all your beams. Okay, but I will just click on the ones that are showing what, warning, that's showing yellow rest. Okay, I believe they are the one that has the link to this cantilever beam of 150 depth of beam. Okay, so with this now, let's now check for this one that is carrying the heaviest load first, which is at the center. Come now and do what, business design. Okay, so on this now, we'll then go and then you can see what's happening here. You can see that here is saying that what, it has what, deflection what issue. Can you see that? So what I'll do right now, I'll have to use what, reinforcement to control this deflection issue on this 150 depth of beam. Okay, so with this now, I'll then come here. First I want to decrease this to what, 20, and then I'll do what, increase the number to 3. It is still having small area. Yes, it is okay, but this small area here, I don't like it, so I'll come now and increase to what, 4. Okay, that's fine. The 2, which is the top, is okay. I'll then come now, this thing is not having a top bar here, so I'll come now and apply top reinforcement on this. Okay, and then come to this place here and increase to what, 3. Okay, and increase to 4. Let me see again, 4. Okay, now I'll have to touch on the top bars. Okay, so on the top now, as you can see, if I increase the top to 3 or 4, you can see that it's still having the same issue. Okay, that means that this 150 beam depth is slightly not okay, because you can see that it has a deflection issue. Okay, so what we'll do right now is to go and increase the increase it to at least, let me say, 175, so that only 25 millimeter will be what, coming out from the slab, which can be corrected by what, using what, by simply using by simply during the plastering, they can be able to cover it up, because knowing that the thickness of what plastering is already 12 millimeter. So what will be left is around 11.5 millimeter, which is very small for anyone to see. So they can use plastering to cover it up on that place. Okay, so let's go and first try if we can use a depth of 175 for on this area. Okay, that's fine. So with that, now I have to come here right now to change the depth of this place. Come here and type 175. Okay, and then say T-bar. Let's see. Okay, so you can see that basically right now you can see that it has now passed on on the check for deflection. So with this, I'll do have to now reduce this number of bar again to 2. Okay, and also for this top again right now, reduce again to 2 again. Okay, so most of you right now have been having this issue here that you'll be seeing this kind of this thing here showing red. That's because you have not extended your bar is not reaching the end of this cantilever. Okay, so just to avoid this issue, you have to come here right now and say extend right to lap. Okay, and this issue here will go, then come now and do increase and do decrease again. You can see that it has now passed. So with this, you can see that 175 is now passing this, although 160 165 would have passed it, but I want to use a figure that is known to the to these iron benders, carpenters at site. Okay, so 150 is known to them and 175 is also known to them. So with this now, we are using 175 as a depth of this place. Okay, so with this now, then do say okay here. Okay, and then you can see that it has now passed. So let's now go and check on the 3D view how this place will look like. So let's just look at now 3D view now, and then let me just go out from this interface now and go to non-interface, and that is on, I don't know, that is on this. Let me see, not on this place. Let's see where that is right now. Not here. Okay, that's on the left here. Let's see. I want to see where that this thing appeared. Okay, correct, that's fine. So you can see where it is here. Can you see that? You can see where it is here. You can see that it's very minimal, small, coming out from the slab. Can you see that? Which they can use. This is just 25 millimeter, because the slab is already 150 and the beam depth now is 175. So only 25 millimeter is coming out from the slab, which they can use plastering to correct and all that. Okay, that's fine. So with this now, let's now go and check for other ones. So I'll back now to my plan view here. So we have checked now for this beam. Okay, and this beam now is simply okay now. Let's now check for this other one too, this other horizontal one here. That will check for this one and for this one too. Right click now and then check section here. That's fine. So you can see how basically it is going. So with this now, then go again right now. This on this side. First, I'll first and treat this other side first. That is here should be 16. Okay, and increase to 3. Let me see. 3 is not okay because it's very small. You can see the area of CDI is small, so 4 is okay. And then here also should be 4 to have a seamless laying of the bar during the construction. So with this again, back to 16 is failing. Increase to 3. What's happening here? Okay, this is okay. That's fine. Then come here. Since here is 4, here is 4. I want to make the support here to be also 4, so I can pass into the support. Okay, that's fine. Then now come now and then treat on this other side here. Now come here and add bar, decrease to 16, and then add a bar here for the cantilever, and make sure you lap this into the, else you'll be having issues. Okay, this one of issues here. So I'll come now and lap, that's fine, and increase and decrease for it to take the effect. Okay, that's fine. So with this now, let's now correct this cantilever, this L over D failure, which is which is the deflection. Okay, by doing increasing the depth to 175. Okay, instead of 150. Okay, that's fine. So with this now, I will then come here, beam here, and increase my 150 to 175, and here also to 175. Let's see if that will work out for that. And then since it worked on the other one, then back here right now. And then yes, that's okay. So come now and reduce the bar diameter and then increase a bit. okay, and then lap the left now into the face of the cantilever. So lap it now and increase and what decrease. Okay, that's fine. So with this now you can see that everything now looks okay here. Then back here again now on this other side also, here also look okay, that's fine. So you have seen how we are able to control this. Okay, so knowing that here is having what here is having 31 point something, I don't like having this because it's a very small area of steel, so I'll do what, increase it a bit. Okay, now there's a reason for this which I did now. If you want to know more secret about that, you have to do what, enroll for our Ekidel mentorship class. Okay, so with this now, then come and then do the same thing here to have this, that's okay, and then also have 3 here, yeah, that's fine. And then come now and do what, say okay here, that's now okay, it is now okay. So with this now, I will then come in, so you can see how we have checked for this now, and then check for this other one too. Now come here and right click here, property here, and then sorry, that design there, and then come now, do the same thing here by increasing to what, 175. Since we already know that 175 is what is going to pass all of the cantilevers, then come here and then come now, add a bar here, reduce the bar first to 16 and add a bar right now, and then make sure I lap to the face to lap, correct. And then sorry, this is a support bar which I'm adding, not a main bar. So I'll come now and click on it here. Okay, click on this part here, which is to add the main top bar. Okay, and then reduce the bar now, the bar diameter, and then increasing the number of bar. First I have to lap what, lap to the right, to the face of the cantilever, and then lap now. Okay, that's fine. So with this now everything looks okay, and that's fine. Then come here and do what, say oh, and here no, here is not okay, so I'll increase. Okay, there are principles you have to do this, so I won't be saying that here. So if you want to know that, you have to do what, enroll for our Ekidel mentorship class. Okay, that's fine. So come here right now and then say okay, and then come now and then click on this here and come here, right click here and do what, okay here, that's fine. And then come again now, increase automatically. Let me see why that is failing. Okay, let me see here right now it's passing with 150, I can see that right now. So I'll just right now and add a top bar to it. Okay, add top bar to it and make sure I lap into the face of the cantilever. That's fine. Decrease to 2 is okay, and then scroll down now to this place here, and then make sure here is what, 175, this or that one here, and then come now. Now the reason why here pass with 150 is simply because the length of this cantilever is what, just 475. Okay, whereas this other one here is what, 747. Okay, so right now I would increase the one that says what, 7. Let me go and confirm that one that says what, 7. This is what, this is beam what, this is beam 25, as you can see right now. Beam 25 is one that is carrying that 747. Okay, then come now and come here, 25, correct, 175. Okay, that's fine. And then come here and then click on this now. You can see that it's now okay. Then add a top bar here, reduce first and then increase to 16, and then increase the number to 2, and then make sure I lap my right to lap. Okay, and then increase and decrease, that's fine. Okay, that's fine now. So with this now, then come here and do what, say come in here is not okay, here is not okay, here I change what, y20. I will then decrease to what, if I decrease now to 16, I'll have to use what, 3 number of what, bars. Okay, I'll then go and do what, use 3 number of bars, that's okay. And here I'll make to be what, 3. Okay, and then here also 3. Okay, so there are some things you're not going to learn while you are on this free channel. So I would like, if you want to know more about structural design, enroll for our Ekidel mentorship class. Okay, so I'll come and do what, say okay here, that's fine. And on this place now, we are not done with almost all, it left with just 2. So I'll do right now again, check on this one. So I want to make sure we are done with all the cantilever beams and that they are all okay. So with this now, I'll have to do what, click on this first and add a top bar here. Okay, 2 top bars, sorry, 2, and make sure I lap. Okay, and then come here and then decrease back to 2, and then come here and make sure I increase this to what, to 175. Sorry, not this place here, not this place. Here is 150 as it is. Here now is what, 175. That's fine. Then come here right now, and then it is okay. Everything here looks okay. And then come here and what, say now okay now. That's okay. So with this again right now, we are now left with this last one here. On this last one, the same thing will still happen. Come here, click here right now, and then come here, and then click on this place here. And first of all, reduce your diameter of bar, and then make sure you lap first, and lap, and then lap to here left, yes, correct, and then increase. Okay, that's okay. And then come here to now correct this failure of what L over D, which is the deflection. Come here and choose 175, which is already convenient for this design. Okay, and then come now, and that's okay, that's fine. Okay, so with this now say okay now. So you can see that we have now checked for what all the cantilever beams are now passing. If also check for this for the other floors, you can see that everything looks okay. But basically, the good culture is that you are meant to check for all your beams, even if they are green. Okay, you're meant to check for all your beams, all the beams, to see the kind of bars that was used to design for your structure. Don't depend on the software. Always check the software. Okay, that's fine. So with this now, you can see that everything looks okay. If we go to our 3D view interface now and then navigate to our you can see how all your beams first are now showing, which can be controlled with what plastering. Okay, then come now and then do what, come to this place here, and then come to here and then click on what, okay. You can see that all the beams now are now passing. Can you see that everything is okay, everything is passing? Basically, slab does not show green, so slab color is always shown as what, gray. That doesn't mean that it is failing. Okay, it has passed. Okay, but all other members of the structure, column, beams, walls, and everything shows green except the slab. Okay, and that's fine. So with this now, you can see that we are now done with what, we are now done with this building. So on our next part of this building, we will be performing what, performing the foundation design. Although I'll not make known to you the one we're going to use for this structure, but we are going to use the one maybe you don't know, I know that. So just not to miss that, I would advise you subscribe to Ekidel if you're not subscribed, and also turn on your video notifications so that at least you'll be known when we post any new video. Okay, that's fine. So with this now, on the next part now, I'll be showing you how to now apply some settings before you can now begin with your foundation design, and then we will now move into detailing. Okay, that's fine. So thank you so much, and God bless you. We love you, and bye for now. Okay. If you want to learn structural design, then Ekidel is the best for you. By clicking the link, you are already one step ahead. Don't miss this offer. Enroll now.